Today we're talking about trig ratios on the unit circle. We're going to be talking about all of them, but we're focusing on sine, cosine, and tangent. Okay? So, this is, before I go any further, this is one of the most important lessons of probably the entire year. Definitely of our study of trigonometry. Okay? So, this is a big one for us. Let's have a little review first. Let's write the radian measures of each of these special angles on the graph. So let's start with 0 radians right here. So there would be the 0 radian mark. And if we go all the way around, we would be to 2 pi. If we start at 0 and go halfway around, we are at pi radians. Okay. If we go a quarter of the way, we're at pi over 2. And I know we've already done this. I know we've been talking about this, but a little review here. If we go 3/4 of the way, we are at 3 pi over 2. And that takes care of all the axes. Okay? Let's now go, why don't we go and do the pi over 4 angles. So here's pi over 4. This would be 2 pi over 4. So this one is 3 pi over 4. This will be 4 pi over 4, so this is 5 pi over 4. This would be 6 pi over 4, so this would be 7 pi over 4. And if we go one more, we get to 8 pi over 4, which is 2 pi. All right, let's do this one. This is pi over 6. We're cutting pi into sixths. So if we go another pi over 6, we're at 2 pi over 6. But 2 pi over 6 is the same as, let me get a little orange here, I think. 2 pi over 6 is the same as pi over 3. So this would be a pi over 3 angle. Okay? If we go another pi over 6, we're at 3 pi over 6, which is pi over 2. Another pi over 6 will be at 4 pi over 6, which is 2 pi over 3. If we go another pi over 6, so we started with 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This is 5 pi over 6. If we go one more, we're at 6 pi over 6, which is pi. Next pi over 6 will be 7 pi over 6. And then 8 pi over 6, which is 4 pi over 3. Then 9 pi over 6, which is 3 pi over 2. Then 10 pi over 6, which is 5 pi over 3. And the next pi over 6 would be 11 pi over 6. So 11 pi over 6. If we go one more, we'll be at 12 pi over 6, which is 2 pi. So doing the pi over 6 angles got us not only all the pi over 6s, but also the pi over 3s, right? Because they reduce. All right, so remember that each of these angles terminate at the ray marked on the graph. Each angle starts at 0. So pi isn't just this line, it is the angle, right? Okay, we are now going to focus on the trig ratios at those special angles. So let's consider the pi over 3 angle. That means it's a 60-degree angle. Back in geometry, you learned the sides of this triangle. Let's go through that really quickly. If this is 60 degrees and this is a right angle here, then that means this is a 30-degree angle, right? If I extend this on the other side and turn it into this would be 60, this would be 60, this would be 60, so we're looking at an equilateral triangle, right? So let's say that this equilateral triangle, I want for this side to be of length 1. So that means that would be half of the whole side. So that means this would be of length 2. And using the Pythagorean theorem, we would get that this is of length square root of 3. So that's the ratio of the 30, 60, 90 right triangle. Every 30, 60, 90 right triangle has that ratio of its sides. Okay, so I'm going to and I could just use 60 degrees as pi over 3, right? I could get sine of pi over 3 using this, but I'm not going to. I'm going to do it a little bit of a different way. Okay, I'm going to do it a little bit of a different way. I'm going to show you the pi over 3 angle. This is pi over 3 right here, right? That's pi over 3. Okay? And I'm going to form a right triangle here like that, so it looks just like the one sitting over there up in the corner. Okay? So, on this triangle, the hypotenuse is 2. I'm going to force this to be a unit circle, and that means that the radius is always 1. So that means that this hypotenuse is not going to be 2, it's going to be 1. So to get this side here, if the hypotenuse is 1, then this leg has to be half of that, right? Because this leg is always half of the hypotenuse. So this is going to be 1/2. And using the Pythagorean theorem, or using the ratio, this leg here would be square root of 3 over 2. So this point up here, that point is 1/2 square root of 3 over 2. Okay? Now, what is sine of pi over 3? Let's use this triangle. What is sine of pi over 3? Sine of pi over 3 is opposite over hypotenuse, so that will be the square root of 3 over 2. I want you to notice something about that. That is the y-coordinate of this point on the unit circle. It's the y-coordinate. Let's do cosine of pi over 3. Cosine of pi over 3 is adjacent over hypotenuse, 1 over 2, the x-coordinate of the point on the unit circle. Okay? Let's do tangent of pi over 3. Tangent of pi over 3, opposite over adjacent, square root of 3 over 1, which is just square root of 3. Okay? Now, to get that, it's always the y-coordinate, sine, over cosine. The y-coordinate over the x-coordinate. Okay? Once we get those, cosecant is the flip or the reciprocal of sine. So this would be 2 over square root of 3, which when we rationalize would be 2 square root of 3 over 3. Secant of pi over 3 is the reciprocal of cosine of pi over 3, so 2. Cotangent of pi over 3 is the reciprocal of tangent of pi over 3, so 1 over square root of 3, and when we rationalize we get square root of 3 over 3. Okay? If we know those, then we can easily get the values for the other pi over 3 angles, the other ones in the other quadrants. So I can get the other pi over 3 angles are these here, right? So 2 pi over 3, oops, way up too high, and 4 pi over 3, and 5 pi over 3. I can, if I know these well, then I can easily get any other reference angle, pi over 3 reference angle. This is in the second quadrant, where sine is positive, but it's a pi over 3, and I know that sine of every pi over 3 is square root of 3 over 2. So it's going to be a positive square root 3 over 2. Tangent of 5 pi over 3, what quadrant is that in? That's in quadrant 4, where tangent is negative, because only cosine and its reciprocal are positive in quadrant 4. But it's a pi over 3. And what is tangent of every pi over 3? Square root 3. 4 pi over 3. Well, 4 pi over 3 is in quadrant 3, where cosine is negative. But it's a pi over 3, and every cosine of a pi over 3 is a half. So if I know these, I can get any pi over 3 angle. That's the ticket. I need you to know these. If you know these, you can get to those. Cosecant 11 pi over 3. What quadrant is 11 pi over 3 in? Well, 11 pi over 3 goes around more than once, right? So I'm going to subtract 6 pi over 3. I'm subtracting 2 pi. This is the same as cosecant of 5 pi over 3. And 5 pi over 3 is in quadrant 4, where sine and cosecant are negative. It's a pi over 3. I know that sine of every pi over 3 is square root of 3 over 2. And if I know that, then I can flip it and get negative 2 over square root 3, which when you rationalize is negative 2 square root 3 over 3. Okay, so I need you to know these three. Know them. Okay? We're going to talk about ways to know these two. But for tangent of pi over 3, here's the way I remember that. Tangent of pi over 3. Pi over 3 has a single 3. Tangent will have a single 3 in it. Square root of 3. Okay. Let's take a look at, so let's remind ourselves here. Okay. On the unit circle, and this is only on the unit circle, for all points on the 1 radius unit circle, x is always, the x coordinate of any point is always cosine of theta. The y coordinate of that point is always sine of theta. And tangent theta is always y over x, as long as x is not 0. If x is 0, then tangent is undefined there. Okay? So let's take a look at all of the pi over 6 angles. So we know where the pi over 6 angles are. I'm going to make this first one in blue, and I'm going to make these other secondary ones. Oops, I got a little bit off there. I'm going to make these other secondary ones in green. Okay, so there's my main one. So I'm going to draw this right here. So here is pi over 6, right? Which is 30 degrees. I'm going to make this. So that's 30 degrees. So here's my 60 degree, right? I know that this distance here is 1. I know that this is half of that. So that is 1/2. And using the Pythagorean theorem, this would be the square root of 3 over 2. So this point is square root 3 over 2, 1/2. Okay? So, now that I have that, now I know, since it's a unit circle, this x coordinate is cosine of pi over 6, and the y coordinate is sine of pi over 6. So sine of pi over 6 is 1/2. Cosine of pi over 6 is square root 3 over 2. Tangent of pi over 6 is y over x. Y over x. So 1/2 divided by square root 3 over 2. And if you multiply top and bottom by 2 here, you get 1 over square root of 3, don't you? But when you rationalize that, you get square root of 3 over 3. How many 3's are in 6? Do you agree that there are 2 3's in 6? So tangent of a pi over 6 will have 2 3's once you rationalize. Now, sine of pi over 6 is a half. Sine of every pi over 6 angle is a half. Cosine of pi over 6 is square root of 3 over 2. How does that compare with the pi over 3 angles? Let me pull that back. Sine of pi over 3 is square root 3 over 2. Cosine pi over 3 is a half. They're switched, aren't they? They're switched. Sine of pi over 3 is square root 3 over 2. Sine of pi over 6 is a half. The cosines are the other ones. So the pi over 3 and the pi over 3 and the pi over 6, they are complementary to each other, right? They are complementary angles because they add to 90, yeah? Sine and cosine are also complementary. That's the meaning. That's why they're called, well, that's why it's called a cosine. It's the complement of sine. All right? So they go together, just like these two complementary angles go together. All right? So how do I remember those? I memorize one of them. I memorize this one right here, that sine of pi over 6 is a half. And if I know that sine of pi over 6 is a half, and I do, then I also know what cosine of pi over 6 is. It's the other one that goes with a half. And then I also know what cosine of pi over 3 is. Because if sine of pi over 6 is a half, cosine of pi over 3 is also a half. That's how I remember those. Cosecant is the flip of, the reciprocal of, sine. So cosecant of pi over 6 will be the reciprocal of 1/2, 2. Secant of pi over 6 will be the reciprocal of square root of 3 over 2, 2 over square root of 3, which when you rationalize, gets you that. What is the flip of tangent of pi over 6? Well, tangent of pi over 6, I'm not going to flip this one. I'm going to flip this one. What's the flip of 1 over square root of 3? Just square root of 3. Okay? Let's go to a different quadrant. So here is 5 pi over 6. Here's 7 pi over 6. Here is 11 pi over 6, right? So what is sine of 11 pi over 6? Well, first of all, which quadrant is it in? It's in quadrant 4, where sine is negative. And then it's a pi over 6. And sine of every pi over 6 is a half. Cosine of 7 pi over 6. Well, first of all, what quadrant is 7 pi over 6 in? It's down here in quadrant 3, where cosine is positive or negative? Negative, because only tangent is positive in quadrant 3. And then it's a pi over 6. And cosine of every pi over 6 is square root 3 over 2. So once you have, these are the reference angles. Each of these are the reference angles. And we know the trig ratios of the reference angles. Okay? Tangent of 5 pi over 6. Well, 5 pi over 6 is in quadrant 2. In quadrant 2, tangent is negative. And then we have the reference angle of pi over 6. Tangent of pi over 6. 6 has 2 3's, so this has 2 3's. That's how I remember that. What about cotangent of 19 pi over 6? Well, 19 pi over 6 is bigger than 2 pi. How much bigger than 2 pi? It would be 19 pi over 6 minus 12 pi over 6. So this would be the same as cotangent of 7 pi over 6. So we are in quadrant 3. Cotangent is positive in quadrant 3. So this is going to be positive. Now, tangent of every pi over 6 is square root 3 over 3. So cotangent of every pi over 6 is the other one, the plain square root of 3. Let's take a look at the pi over 4 angles. Okay. Get our pi over 4 angles here. Let's see. Here's pi over 4. Okay. Here's 3 pi over 4. 5 pi over 4. 7 pi over 4. All right. Let me get this going down like that. Okay. So here's pi over 4 right there. And we know that this radius is, well, it is a radius, but it's also the hypotenuse of that triangle. That is of length 1 because this is a unit circle, 1 unit circle. So we could use the Pythagorean theorem on this, and we would get that each of these is 1 over square root 2. Each of these is 1 over square root 2, which when you rationalize is square root 2 over 2. So this point out here is square root 2 over 2, square root 2 over 2. It's a 45-degree angle there, pi over 4 angle. So the x and the y have the same coordinates. So sine of pi over 4 is the y coordinate at pi over 4 on the unit circle. So that is square root 2 over 2. Cosine of pi over 4 is the x coordinate on the unit circle. So square root 2 over 2. What is tangent of pi over 4? Well, it is y over x. But since y is equal to x, tangent of pi over 4 is 1. Cosecant of pi over 4 is the flip of sine of pi over 4. But I'm not going to flip that. I'm going to flip the 1 over square root of 2. This is just going to be square root 2. Secant of pi over 4 is the same thing. Cotangent pi over 4 is the flip of tangent pi over 4, so it's still 1. When you go to a different quadrant, you're going to use these, but possibly change the sign, right? Depending on, all students take calculus, the sign of that trig ratio in that quadrant. So what quadrant is 3 pi over 4 in? Excuse me. 3 pi over 4 is in quadrant 2, where sine is positive. The reference angle is pi over 4, and sine of pi over 4 is square root of 2 over 2. I need you to just memorize that. I need you to memorize these here. Get yourself some flashcards, do whatever it takes to memorize that. Okay, tangent of 3 pi over 4. We're still in quadrant 2, where tangent is negative. It's a pi over 4 reference angle, and tangent of every pi over 4 reference angle is either 1 or negative 1. Cosine. What quadrant are we in? 7 pi over 4 is in quadrant 4, where cosine is positive. The reference angle is pi over 4, so cosine of a pi over 4, square root 2 over 2. Secant of 3 pi over 4. 3 pi over 4 is in quadrant 2. Secant is the reciprocal of cosine. So this is negative. And then it's secant of a pi over 4 reference angle. So we're flipping cosine. This is going to be square root of 2. Alrighty. Let's take a look at our axes. So now I'm going to highlight here these axes. Okay, what point is this right here? When theta is 0 radians, what point is that? That is, if it's a unit circle, which it is, it's a unit circle. So this must be the point 1, 0. What point is up here? That is the point 0, 1. This is the point negative 1, 0. And down here at 3 pi over 2 radians is the point 0, negative 1. If we know those, we can get to all the trig ratios because the x coordinate on the unit circle, only on the unit circle. If the radius was 10, this would not work anymore. But on the unit circle, x is equal to cosine theta. Y is equal to sine theta. Okay? So if I want sine of 0, I go to 0 and get the y coordinate, 0. Pi over 2, the y coordinate is 1. Sine of pi, go to pi, the y coordinate is 0. Sine of 3 pi over 2, the y coordinate, negative 1. Sine of 2 pi, we're back to 0. Sine is 0. Cosine. Cosine of 0 is the x coordinate. So 1. Cosine of pi over 2, the x coordinate at pi over 2 is 0. Cosine of pi, the x coordinate at pi is negative 1. Cosine of 3 pi over 2, back to 0. Cosine of 2 pi, 1. Okay, let's go do tangent. Tangent of 0. So remember that tangent is always the y over the x. Okay, and that's always true. In fact, that is always true even if you're not on the unit circle. This is always true. So tangent is always y over x. So tangent of 0, we go to 0 radians. Here's 0 radians. Y over x, 0 over 1 is 0. Let's go to pi over 2. Tangent of pi over 2. 1 divided by 0. Well, what is 1 divided by 0? That is undefined. So we write undefined. Tangent of pi. Y over x, 0 divided by negative 1 is 0. Tangent of 3 pi over 2. Y over x, since we're dividing by 0, this is another undefined one. And then back to 2 pi, y over x is 0. Okay, let's do cosecant. Now for cosecant, I'm going to think of sine. It is the reciprocal of sine. So cosecant of 0 is the reciprocal of sine of 0. This is 1 over sine of 0. But what is sine of 0? Sine of 0 is 0. That means it's 1 over 0, and 1 over 0 is undefined. So this is another undefined one. Cosine of pi over 2 is the flip of 1, so not cosine, cosecant. Cosecant of pi over 2 is the flip of sine of pi over 2. Flipping 1 is 1. Cosecant of pi, the reciprocal of sine of pi, another undefined, because sine of pi is 0. Cosecant of 3 pi over 2 is going to be negative 1. Cosecant of 2 pi is another undefined. Okay. Secant of 0, that's 1 over cosine of 0. Cosine of 0 is 1, so we flip 1 and we get 1. Secant of pi over 2. Cosine of pi over 2 is 0, cannot flip it, it's undefined. Secant of pi, flip negative 1, we get negative 1. Secant of 3 pi over 2. Flip 0, can't do it, undefined. Secant of 2 pi. Flip 1, 1. Okay. Cotangent. Now cotangent, we can get there two ways. We can either do it as 1 over tangent, or since tangent is y over x, cotangent is x over y, right? Always. It's x over y. I say that because there are lots of places when tangent is undefined. And you cannot flip an undefined, right? So it might be easier to think of cotangent as x over y. Okay? But let's think about this. So cotangent of 0, 1 over tangent of 0. But tangent of 0 is 0. Can you do 1 over 0? No, this is an undefined. Cotangent of pi over 2. Well, tangent of pi over 2 is undefined. Can you flip undefined? No, it doesn't make any sense. So, but how did we get there? How did we get this undefined? We got this because tangent of pi over 2 was 1 over 0, but cotangent of pi over 2 is 0 over 1. So everywhere that tangent is undefined, cotangent will be 0. And everywhere that tangent was 0, cotangent is undefined. They just switch. So cotangent of pi, tangent of pi was 0, so cotangent of pi is undefined. Tangent of 3 pi over 2 is undefined, so cotangent of 3 pi over 2 is 0. Tangent of 2 pi is 0, so cotangent of 2 pi is undefined. Okay, there is another way to remember these points on the unit circle, these coordinates. This ordered pair here, the coordinates right here, it's the point 1, 0, right? This point is 0, 1. It's a unit circle, so it has to be that way. Okay, for these three middle points, there's kind of a trick to remembering those. I'm going to do the first parentheses of the ordered pair. Okay, so here's how you do it. First of all, you have to remember that everything has a denominator of 2. Everything has a denominator of 2 here. All of these, there are 6 pieces, and each of them has something over 2. Every one of them, something over 2. Okay? Now here's the way to remember it. And I don't care where we start. Let's start with the sign. Let's start with the y coordinate. Okay? This first numerator. 1, 2, 3. 1, 2, 3. Except we put square roots on them. Square root of 3, square root of 2, square root of 1 is just 1, so I'm not going to square root 1. That's how you get it. So 1, 2, 3, square rooted. For the x coordinates, it goes opposite. It goes 3, 2, 1, and then square root. But don't square root 1, because square root of 1 is just 1. Okay, so easy peasy. And now all you need to remember is that that's cosine, and this is sine. Alrighty? So, that's the way to remember those. Well, a way to remember those. Okay? And then to get the other quadrants, you go use all students take calculus. Tangent of pi over 3. Let's do the tangents. Tangent of pi over 3. A single 3, a single 3. Tangent pi over 6. 6 has 2 3's, so square root 3 over 3. Tangent pi over 4. Pi over 4 is that's your middle, right, where x is equal to y. So tangent of pi over 4 is 1. So those are some ways to remember that. Alrighty. So we are going to be spending the next several days just doing these, okay? Doing tons and tons of these to where you are going to get super comfortable and familiar with these, okay? So we're going to try to do this page without going back and looking at our unit circle. Okay, so let's take a look at this. Sine of pi over 6. This is the one, if you memorize this, the others should fall into place. Sine of pi over 6 is the one that I truly just memorize. Okay? I've taught a lot of kids these trig ratios, okay? My own daughter, years and years and years ago, taught her these trig ratios. And if I ask her today, and it's been years since she's seen a trig function, but if I asked her what sine of pi over 6 is, she will spit out 1/2. And she says, I don't know what that means, but I know it's a half. I'm like, okay, that's good enough for me. This is the one to memorize. If you know this, sine of pi over 6 is a half, then cosine of pi over 6 is not a half, it's the other one. It is the square root of 3 over 2. It's the other side of that, okay? It's the complement of that, okay? All right, and if I know sine of pi over 6 is a half, then sine of pi over 3 is the complement of pi over 6, so it's not going to be a half, it's going to be the other one. It's going to be the square root of 3 over 2. Cosine of pi over 3 is the other one. Yeah, I mean, it's pi over 3 is the complement of pi over 6. So since sine of pi over 6 is a half, cosine of pi over 3 is a half. So those four just fall into place if you know sine of pi over 6. Okay? Tangent of pi over 3. For tangent, a single 3, a single 3. For tangent of pi over 6, 6 has 2 3's. So tangent of pi over 6, 2 3's, square root 3 over 3. Now, I will say, this came from, we had to rationalize 1 over square root of 3, but I don't think of it like that because when you see this, you only see 1 3, right? And I want you to think of it as having 2 3's in it, but it did come from this, okay? And I say that because if you flip this for cotangent, you're going to get the square root of 3. Sine of pi over 4. Well, you can think of this a couple of different ways, but 4 does have 2 2's in it, doesn't it? So, square root of 2 over 2. Cosine of pi over 4, square root 2 over 2. Tangent of pi over 4, sine over cosine, but they're the same, so 1. So I don't think that this is too much to get you to memorize, but this up here is what I need you to know. Okay? So number 1, sine of pi over 6 is a half. Cosine of 2 pi over 3. Let's get the sign. What quadrant is this thing in? 2 pi over 3 is in quadrant 2, where cosine is negative. Now, look at the reference angle. It's a pi over 3. Cosine of pi over 3. Well, cosine of pi over 3 is a half. So, get the sign and then get the value. 7 pi over 4. 7 pi over 4 is in quadrant 4, where tangent is negative. Now, the reference angle. The reference angle is a pi over 4. Tangent of every pi over 4, 1. Sine of 5 pi over 3. Well, what quadrant? 5 pi over 3 is almost to 6 pi over 3. We're in quadrant 4, where sine is negative. And now, what's the reference angle? The reference angle is pi over 3. Sine of pi over 3, square root 3 over 2. 3 pi over 2. 3 pi over 2 is not in a quadrant, it is on an axis. It's down here. So for that one, I will name the point. This is the point 0, -1. Cosine is the x coordinate, so this is 0. Tangent 5 pi over 6. What quadrant are we in? 5 pi over 6. It's not all the way to 6 pi over 6, so it is right here in quadrant 2, where tangent is negative. Now we'll get the value. It's a pi over 6 reference angle. Tangent of a pi over 6, 2 3s, 2 3s. Okay? Sine of 3 pi over 4. What quadrant? 3 pi over 4 is in quadrant 2, where sine is positive. And it's a pi over 4, sine of pi over 4, square root 2 over 2. Cosine of 11 pi over 6. What quadrant is 11 pi over 6 in? It's down here in quadrant 4, where cosine is positive, and it is a pi over 6 reference angle. Sine of pi over 6 is a half, so cosine of pi over 6, square root 3 over 2. One more. What quadrant are we in? 4 pi over 3 is 1 pi over 3 higher than 3 pi over 3, so it is in quadrant 3. And tangent in quadrant 3 is positive. It's a pi over 3 reference angle, and tangent of pi over 3, single 3, single 3. Okay, so I know what kids think of this first day when we're doing these values. I get it. There's only one way for you to grasp this stuff, and that is to do problems. Do lots and lots and lots and lots and lots of problems. So we will be spending the next couple of days only doing this. All right? So you must do your work. You will not learn this if you don't do your work. So you must do it. So go do your homework for this section. Oh, are we done? Let me see. Did I finish? Yeah, I finished. Okay, that's it.